Hello, everyone, and welcome to another Grafana Office Hours. I am Nicole van der Hoeven, developer advocate at Grafana Labs, and over there is my sidekick.
I am Paul Balog, yet another developer advocate at Grafana Labs.
And today we are joined by Matt Durham. Can you introduce yourself?
Hello,
Who am I
I'm
at? I'm
Matt
so bad
Durham.
at this.
I'm a developer here working on the agent that we're going to talk about today. And yeah, I'm located here in the States in Louisville, Kentucky.
Hey, and I just happen to notice now on your name and everything there that you do not believe in capital letters. You
Yes.
you are all lowercase letters.
It's the Cool Kids Club.
It's-
Oh, okay. So we're apparently not cool enough.
Well, you got to be official. You're like the face of the company. Me, I'm just over here toiling in the mines of code.
Yeah, we're very professional over here. No funny business at all.
No,
Today, we're going to
serious.
be talking about Grafana Agent and, in particular, flow mode. We've already talked about Grafana Agent before, and I've briefly mentioned flow mode, but Matt today is going to be telling us all about it and answering all of our questions. So, we're going to talk about what it is, how it's different from static mode, and I guess which one to use and how to use it. But first, let's go over some announcements. Our colleague Lisa has just created this video called "What is DevOps?" And we are going to put a link to that in the description below, or you can check out over there where I'm going to put a card that you can click on. We are we are actually streaming a previously recorded version of this episode, by the way, because happy Thanksgiving, or I think it's a day after Thanksgiving by the time this goes live. And we didn't want to be here for that and ruin all the Americans, meaning the other two's
This is
holidays. So we're doing it pre recorded. But
exactly
if you
because
do have
on Black
questions,
Friday you have to recover from your tryptophan hangover
oh, yes.
from the
Sure,
turkey.
I will be definitely partaking of that here in Europe. The other thing is our other colleague, Marie Cruz, also just released a video about a week ago called Grafana K6 for Beginners: Why Observability Needs Testing. Click on the link over there. And we have an observability survey for Grafana. So this is like a bit of like this is so we can create this cool infographic about, the tools that people are using, whether or not you're using AI and how, what are you excited about, and what are your concerns regarding observability and reliability, and basically your observability strategy, yours or your teams and the companies. So we have done this. We already did this last year and we had some interesting results. So if you'd like to kind of have your voice heard too, then check out that link or in the description below to take that survey.
You know what? I have foresight. I see flame graphs. I see flame graphs in this year's survey.
Did you see that when you looked down at your own shirt? That was just an excuse to pump that,
Well,
to kind of show off the merch that he has
that's
that we
right. The
don't have.
swag that I was
Right.
able to get at KubeCon.
Mm,
So
We're all representing today, but Matt is also representing Grafana. While you're showing us what you're wearing, could you talk about a little bit about when you joined Grafana and what you do?
sure. I joined Grafana 3 years ago this January, so coming up on my 3-year anniversary. And I was the second member of the agent team. And I guess here in a minute, I'll actually go over what the agent actually is. But I've worked with that team for the whole time I've been here, and now we've grown to, I don't know, a lot more people, like 10, maybe more
oh
than 10.
wow.
Yeah, so it's grown a lot here recently, and the just kind of been growing and adding more functionality to kind of meet the needs of everybody who uses it.
So you
Nice.
joined the agent team right away.
I was the second, yeah. So it was ran by Robert, I think a year or so before I joined. And then I joined primarily to do some of the Windows stuff. Not the most exciting thing, but needed to get done. And we've done a lot more exciting things since then.
Awesome. So we already did a Grafana Office Hours with Paschalis Cilias. That was a few episodes ago, and he talked all about Grafana Agent. But just for people who haven't seen that, could you give us like the quick explanation of what is Grafana Agent?
Absolutely. So the Grafana Agent, our tagline is a kind of a vendor neutral collector of signals, so metrics, logs, traces, profiles, all sorts of fun things. And essentially, I always like to say it's like plumbing. It is used to move from your, maybe you have a VM or a Kubernetes cluster you need to get metrics from, and you can move it to Grafana Cloud or any other uh, OTel or Prometheus compatible endpoint. So we're not particularly tied to using Grafana Cloud. You can use the agent without paying us a dime.
That whole big tent thing.
Mm-hmm.
Work and
Yep.
Yeah.
play well with others.
Yep. We want to be the default collector no matter who you're using or what you're doing.
I love the metaphor of plumbing because, I think it's not really the most exciting thing. People don't typically think, the collector that they're using when they think about observability strategies, but you need some way to get that information. So it is something that you have to consider. It's just not one of the more interesting
Mm-hmm.
topics that most people think about. It is actually super important.
Yeah. Ideally, you set it up once and you forget about it, and hopefully it just works, which is how you want your plumbing in your house. You never want to have
Exactly.
Exactly.
anytime you think about your plumbing, it's never going to be a good time, but it's incredibly important to have working.
Definitely.
All right. Well, we also talked a little bit about static mode with Paschalis in the previous office hours. What is that? Why are there modes to Grafana Agent?
So the static mode is kind of the original mode, which was a fork essentially of Prometheus. And we kind of removed the bits that we didn't need that was required just to move data, because Prometheus comes with like a whole UI, it comes with actually long-term storage, and we identified a need for having something much more lightweight that allowed you to move signals from essentially from wherever you're collecting them to an endpoint, Prometheus, Mimir, Cortex, Loki, all the other slew of products there. And that was kind of how the collector or the static agent started. And it was very much, if you look at the configuration, it's very much derived from Prometheus. And that was kind of the initial push. And it went along for, I think, about 2 years before we started really reevaluating what we could do and maybe the next step of the evolution of the product.
Nice. Yeah, I feel like on my home VPS, I have Grafana Agent running on there in static mode, and it just seems to run, and I don't mess with it.
Yeah, and that's how we really want it to be, is that it is something that generally you set up and it just runs kind of in the background until you need it or need to adjust something. But with a lot of people, they just run it and it works. And, we kind of started evaluating what the next evolution was. And maybe that's what led us to, we have these projects where we kind of dig into things and kind of play around with more experimental things. Um, and roughly, I think about 2 years ago, me and Robert were working on some things, and we decided we wanted to really kind of have this concept of like what we'll call a telemetry pipeline. So if you look at like the OTel collector or a lot of other products in the market. They have some sort of pipeline where you kind of chain processors and sinks and sources, and there's a lot of different names for it. And that seemed like a really flexible. We were kind of hitting a limit on how to chain things together to really meet everybody's needs. And that kind of, we started experimenting with stuff, and there was a lot of different options there. So we played with it and started to come to this idea of a component-based architecture.
So, why is a component-based architecture important?
So I have a lot of experience in like traditional ETL pipelines, extract, transform, load.
Yeah.
Where you're, I had to think, I know the acronym,
That one I
think
know.
about it for a second. Yeah, where you're essentially moving data from one spot to another and transforming it. And for us, signals or telemetry data are the same. That most people don't want the raw output. They want to massage the data. They want to transform it. They may want to limit it. They may want to take other actions on it. And the existing static agent really, it had some capability there. And it was very easy for simple things, but it was very, very difficult to handle kind of more advanced use cases. And it was getting difficult to develop and make sure that we were meeting kind of the needs of the people using it. The static mode is very easy for very basic stuff. In fact, it's better than Flow when it comes to very simple use cases. But we found that there were more and more people who were having very advanced use cases, and that's what led us down the road of kind of identifying the fix and what we're Flow. There's a whole lot going on here with Flow, and we have River, which is the language that Flow configuration is written in.
So if you
And
were just doing the simple forwarding type, no transformation on the data format or anything like that, static is just the way to go then. If you're that simple case.
If it's a very simple use case,
Yeah.
if you're starting out new, I'd recommend Flow because that's where we're putting most of our attention.
Yeah.
But static mode is very quick to get up in a very simple use case. But it starts to fall apart when you start looking at more complex scenarios or different signal types. It is really limited to primarily a Prometheus Loki, and then Tempo's OTel, so you get that. But it is not has maybe Big Tent in the sense that it handles a lot of metric types, where Flow is OTel native. And that's kind of a big thing that we're moving toward.
Onto that standard for open telemetry, you mean?
Yes.
Yeah.
Yes. Sorry.
Cool.
Open telemetry is a big thing, and it's we'll always support Prometheus and all these others, but we recognize that hey, there's a whole world out there of signals that aren't Prometheus.
Yeah.
And we want to make them first class citizens.
Well, I know on a side note, I mean, at KubeCon this year in Chicago, there was Observability Day. And then, I mean, which is kind of an open telemetry thing. And I mean, it was packed. That was, there's a lot of people interested in that. And I mean, and it's obviously because it's it's an open standard. It's, for the metrics and everything else.
Yeah, and we kind of package it all together. So we import most of the open telemetry components and the functionality that they provide. And then we also add our additional functionality on top of it. So for instance, we say we're batteries included, which what that means is we have a whole lot of exporters built in. Do you want Windows, Linux, MySQL, MS SQL, lots of databases, SNMP, lots of things out there that maybe are not within currently kind of within OTel's wheelhouse. We're including, and we even allow you to transform metrics from Prometheus to OTel and back. So you can get whatever you need in whatever format you want, be able to transform it, and then send it out in whatever format you want. kind of one of our things we want to focus on is we don't want you to have to think, okay, what format of the metrics do I need? What protocol? The idea is agent and agent flow inherently can handle the metrics that you've got and be able to transform them into whatever you have.
So I think that static mode is like when you do the configuration for it, it is a YAML file, right? So
Yes.
I imagine that that is, on one hand, it is something that's familiar, but on the other, it can kind of be restrictive if you want to do more things than just set things up and set the end goal in a declarative kind of way.
Yes. So this is probably the most controversial part of Flow is going away from YAML. And we have a whole document conversation in our GitHub repo about it, which I will add a link to. And I guess or someone will add a link to it in the YouTube description. But it kind of goes over a process of why we went over this, and we actively did try YAML, and we found for what we were wanting to do, which was creating essentially a pipeline, it didn't, I want to use this word, flow as well as maybe as it should have. And maybe so what we maybe jump into is I can share a little bit and we can look at like a river config, and maybe that will give a visual of what we've got going on. So this is a very straightforward. It's got like 8 components. This is all about the OTel configuration. And if we conceptually think about these components talking to each other by sending messages between one another, that's kind of at a very high level how River works. And it uses what we call expressions, which are, an expression is essentially a statement. So in this, it says, hey, set the endpoint that I'm going to receive gRPC OTel to, localhost 4317. But it also can do things like this. Like you can username equals, and then I have an environment that's username. And furthermore, I could do a plus here if I wanted to add, maybe the host name to the username. Maybe that's some special sauce they have going on. I have an example that's probably a little smaller that shows that. So this is just an example I have here. These are not all real components, but it kind of takes that kind of larger config and just kind of shows some of the power of what we call expressions, which if we narrow down to password here, so if we have a component that takes a password, we have a coalesce command, which is basically return the first not null or not blank value. So in this case, we look for an environment variable password. We check a local file to see if it's got like the password. And then we kind of chain that to try to get a remote value password. Now we tried to implement this in YAML, and it ended up looking insane, and it would require us to have a very difficult parser to handle this kind of
that
statement.
logic. Yeah, that's I can imagine.
There was some difficulty with the parsing was the really hard part, because basically we would have to slam this into the YAML, parse the YAML, and then parse this. So we ended up basically writing a parser anyways. And we were like, hey, we can do this better. And you'll notice that this looks very much like HCL, which is commonly used in Terraform. And that is kind of on purpose, because we started with a fork of using HCL, and we ended up having to make enough changes to it that we decided to just basically write our own language that was heavily influenced by HCL.
All right, so let's talk a little bit about HCL. So that's HashiCorp configuration language, right?
Yes.
And Terraform. So there is a little bit of a precedent for it, because Terraform is a tool for infrastructure as code, but YAML is also used for infrastructure as code. So there are kind of two different ways to do it, and you seem to have gone towards the HCL side. why did you not stick to HCL? Like, what were the things that made you think like we really need to create something of our own?
So HCL is kind of a run once then apply. So generally you're saying something like spin me up a new environment or set up a new database or apply some kind of functionality to an existing infrastructure. I like to use the phrase runtime configuration
Mhm.
with Flow. So Flow is constantly being evaluated. So for instance, if the content, this local file that's reading this password.txt, I think by default it's reading that every minute. And if it changes, it's kind of propagating those changes down. We have a DAG, directed graph, cyclic graph, that will find anything that depends on this local file secret, and then it will update this component with that new value. So it's constantly kind of like reevaluating itself as things change. And we found the default HCL was not performant in this regard. It very much had a lot of things about like copying values. And when we have a very large graph with a lot of nodes and a lot of data being moved between them, that became a performance bottleneck. And that was one of the reasons we shifted away. And we also wanted to kind of define some of our own kind of grammar and concepts there.
Okay. So let's talk a little bit about why, like, the things that Flow is.
Uh-oh.
Uh-oh.
Here it happened. Uh-oh, we lost her. We lost her. I had no idea where. Oh, there she
You're
is.
back.
There
I'm
she
We
is.
back.
lost you for a
I'm
second.
just trying to think,
Yeah.
where was she going with this question?
Yeah. Why couldn't you read my mind, Paul?
Yeah.
I was
That's
just
that's the
asking.
superpower I'm lacking.
So I'm thinking about things that are hard to do in static mode that are easier in flow mode. And one of the things that you mentioned is being able to better being better equipped for ETL pipelines.
Mm-hmm.
So is this something like maybe converting metrics like from Prometheus to some other, like transforming them in some way?
Yeah, that's a big goal. So one of the other things that kind of drove it is the ability to reuse. I kind of mentioned expressions, which are, if you think of it, it's like a line of code that essentially gets compiled to a reference here. And we had so we had an example of like a Vault integration, which Vault is a way to store secrets in a remote storage. And we wanted to be able to, people wanted to be able to hit the remote vault and then basically be able to get secrets out of it ad hocly and be able to reuse them. So like if I wanted to, I could add a vault dot blah, 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 blah here and give it like a key name. And that could be in this kind of big password field. And that was something that YAML, again, didn't really offer much advantage in. We also, another thing that was really painful with YAML is if you've ever written some YAML and you've passed it to something that parsed it like a program or agent, you generally get a very obtuse error message. You get like, hey, we couldn't convert, this string to this type struct, and it errored out, and maybe it gives you the name of that struct it tried to do. We were able to rewrite the error handling. So we'll tell you exactly what line, and we'll actually spit out the error of what went wrong with the configuration. And it will give you a lot more detail. We'll tell you exactly what went wrong. And ideally, in a future world where we're kind of iterating on the river language itself, we'll be able to give more examples of how to fix it, or here's more help. The idea is to give more context to why something went wrong. And that just is not available in a YAML world where you're just kind of verifying the schema is correct. Where this, we can actually give a lot more detail that like this type is incorrect. and that this value is required. And there's ways to do that in the YAML world, but they're a lot more difficult.
It almost seems like it's a way of offloading some of the logic to agent. It's improving the functionality of agent, and maybe some of these things like the transformations maybe would have been done further downstream. Is that correct?
You could, so this kind of goes to the in static mode, hard things are real hard, and some of the transformations fall under that. Like there are
Mm,
ways to make them happen, but they require they require more magic. So in
mm,
the code of static mode, things are hooked at a programmatic level where like assumptions are made, and those assumptions are not really visible to the user. And so when you start running up against those pitfalls, it becomes very hard for a user to figure out, okay, what am I doing wrong here? Why is this system not working? Where in River, where you're kind of having to create the relationships as you kind of move through the system. If you have a scraper that's scraping a set of metrics, you then pass it to a remote write or a relabel rule that kind of transforms the metrics in whatever way you want. So you can kind of see that. And then we also kind of built a UI that gives you a better, more in-depth look at what's going on in your system. And because each component kind of is responsible for how the UI is driven, there's a default one that most use. It allows you to, each component can give you very detailed information about what's going on. It's very difficult to do in the static world. And if we can share here, and I can give you a little view of what that UI looks like. So at the very high level, we have a graph here, and I happen to use Firefox, and we have a slight off kilter with Firefox. If you see this, the text doesn't exactly line with the box, but ignore that. But this shows how all this is a graph. This is the graph I talked about earlier that shows how everything's related. So here we have a receiver at the top. It sends it to the batch, which then sends to the memory limiter, and then it gets exported out, whether it's a trace, a metric, or a log. And then I can click on one of these and get a little bit of detail. So you can see here, I can get the configuration that was passed to it. It'll give me some kind of details. We have a link to our documentation, which is fantastic. Both that the link is there, and we have taken this chance to revamp our entire documentation. So that's super exciting. And then we have these things called capsules. Those are essentially structs or functions or objects that can't easily be represented in a textual format. And then you can see all the dependencies and the dependents and make sure they're healthy or not. So this gives you kind of a quick way to look at your running system and be able to diagnose things. And this is something that would have been extremely hard to do in static mode, where things are, they don't follow the same pattern, but as we've developed this component-based pattern, where every component has to expose certain types of data, it becomes very easy to kind of build this rich UI.
It's nice. So, and it determines all those dependencies, like so the one component depends on a prior component and all that. So,
Yep. So if we look here, this memory limiter, and I go back to the config here, and this is the string representation of that. Here's the output. So this is the things that it's sending data to. And then this up here is what is sending it data. So we want to kind of give, because this, I have an old presentation from like, at this point, 2 years ago, where basically I drew out this. This was like my original vision of like having a left to right, your inputs are on the left, data flows, and it goes to the right. And in like I had this, grand idea of you could see like little packets moving on the little arrows, or like, you could click on it and kind of drill down. We're not there yet, but this does give a lot more kind of being able to get your hands on how the system is working and kind of drill down into it.
Yeah,
That
no,
we
I
just don't
mean,
have in
just
static
that
mode.
right there is pretty huge, just to be able to visualize the configuration, just
Mhm.
to see how the data is going to flow, you know.
Yeah. And then there's some other kind of documentation is something that often is lags behind in software. That might be a polite way of putting it.
What do you mean?
Um,
Everybody loves to write docs. Are you kidding me?
yeah, but
Saying that it lags is a big assumption. You're assuming they exist.
yes, and our own static mode, because we imported projects and we just imported their configuration and basically embedded it, that you will see a lot of documentation in the static mode that is like a link to Prometheus or a link to
Mm,
OTel. And the problem is those links can change, or they can go away, or they can get out of date, or you know options can change. And sometimes we did not find when that happened, and people would be like, hey, where's this option? And be like, oh, it's not available yet, we haven't updated our dependencies. So one of the big things we wanted to take here was have, whenever we add a new feature of component, it is a requirement that it has reference documentation. So so this is like we need to embiggen that. There we go. So our documentation here, super awesome. This one has, it's all broken down in the same way. We go through everything that you can set, all the defaults, and it's all in one place. And it's all kind of within Grafana.com. You don't have to reach out to look at documentation elsewhere. We pull it in, and whenever we update a dependency, we check to see if something changed and then update the documentation. So the idea is the documentation of what you're dealing with always matches with what the agent expects. And so we've gotten a lot of good feedback on that, of having this kind of cohesive, strong documentation. And we could have done that with static mode. There's nothing that would prevent that. But part of it would be having to go back, dig through it, make sure we have everything right. Um, and since we had all these other benefits of moving to Flow, we took it as kind of, we really need to push and have really great reference documentation. One thing we're currently lacking on is task-based documentation, but it's something we're working on.
So, performance-wise, how does static mode compare to flow mode?
Almost the exact same. That was one of the first big stumbling blocks, is we had to ensure that performance, I think, was within 5%, but I think we ended up hitting 1 or 2%. And that's one of the reasons we had to switch away from HCL. The performance of figuring out the graph itself and then updating the graph had to be extremely minimal and not impact the actual processing of data. And we found with HCL that was kind of a limiting factor, when we could be updating the graph, tens of times a second of things changing. And when we kind of pivoted to River, we found that it's less than, probably, in the more data you're handling, the more that percentage goes down. But in a very kind of like basic way, where you're just getting the local machine, it's like a 1% overhead. If you got something where you're doing a lot of stuff, it's even lower, comparatively. Because
So that's
eventually the processing of data consumes more CPU than the processing of the graph, by far.
so you're saying that the performance is pretty similar. What
Yes.
about scalability? Like if people want more than one or need more than one instance of agent, I know static mode, because it's more Prometheus based, uses hash mod sharding. What
Yep.
about flow?
So hash mod sharding is basically, you write the data at least twice. or we do for high availability. HashMod lets you distribute it, and then we write it twice to ensure high availability. And this allows you to get away with scaling the agents. That's very expensive to do. So when there's also a scraping service mode, but it is a little finicky, so we won't cover it for static mode. And we used HashMod with high availability internally. And when we did streaming or flow mode, we knew we wanted to introduce a smarter clustering option. And so we introduced, we use a version of DSKit, CKit that is used in a lot of our products, a lot of the open source projects that creates shards the data. And the clustering that we built, we were able to roll it out in all our internal environments that operated a pretty high, thousands of targets. And we were able to reduce cost of those by like 50%. Because essentially the clustering gives us highly availability without having to duplicate things. And it's also far more flexible than HashMod sharding, where HashMod sharding, you have to know upfront how many nodes you're going to be running. And if you change that, you have to roll that configuration out to every one node. The clustering that we now have in Flow is much more flexible in that regard. It's not quite like every second you should be adjusting it up and down, but if you need to add a node or remove a node, generally within, I think, about 10 seconds, it's rebalanced at half the cost. Literally, I think we hit half the cost that we were running with static mode.
Wow. Can make that any better?
Yeah. Maybe. But
wow.
we'll
no,
take
that's
the
good.
50%.
Yeah, right. That's awesome.
Can you talk a little bit more about that? Because I don't quite understand how HashMod sharding works in the first place and what
Yeah.
you did to improve. Because it seems like a pretty significant case for using flow mode.
Yes, so HashMod sharding by default, whenever a metric comes in, the general use case is you do a hash of the metric name, and then that gets a number, and that number, like if you had 5 shards, that number would be 0 through 4. And then if it was and you had to specify which shard that one was, and if it matched, it would keep it. If it didn't match, it would drop it.
Drop it.
So this way you could kind of scale the collection across a number of agents without overloading, having to either have a very tall agent that just handles everything. You could have a number of you could go wide with the number of agents. Now that gets you scalability, but it doesn't get high availability. So what we did in addition to that is we used a Mimir has essentially there's a leadership process where you can set some flags that basically say you're going to get multiples of the data, whichever one comes in first, take it. That's a gross simplification of all the things going on there. But then we wrote the data twice. So if we had 5 shards, we really were running 10. 5 leaders, 5 backups. With the clustering, we only need the 5. And then if one goes down, within about 5 or 10 seconds, they've rebalanced. And maybe you lose one scrape. The general scrape is every 60 seconds. So if maybe if you were right on that verge, you might lose one scrape, but we generally tend to see, we're not a ACID transactional database. If you lose a little bit of metrics, well, because you're rebalancing, that's not the end of the world.
Right.
But it could be smaller than that, so it's unlikely. Depending on your inner region traffic, you could maybe lose one metric, but it's the offset of being able to save a whole lot of CPU and memory is well worth it.
Okay, so that makes sense. All right, so I like what you said, that the HashMod sharding is good for scalability, but not necessarily availability, and that's really a key point.
Yeah, it's very inflexible. and we had a lot of issues with people running it and wanting to have a more elastic demand. And the clustering has been developed to basically be far more elastic in terms of being able to scale up and scale down. And we've only really talked about the concept with metrics, which that's all really the static mode is supported. But with Flow, we each kind of component type can implement its own version of clustering. So it is something we can roll out to logs or trace receivers that can bring clustering and ideally cost savings to those types of signals also. That would have been very difficult to do in static mode.
Okay. Can you talk a little bit about some of the features that are unique to Flow other than clustering? We talked
Sure.
about what the things that are hard about static mode already.
Yeah. So most new developments going into Flow mode. So this list is only going to increase as time goes on. Probably our largest kind of marquee feature is our OTel support. In static mode, we basically supported Tempo, which is OTel native traces. We in Flow mode, we've extended to all the OTel signal types, their metrics and their logs, and then traces comes along for free. And we've also been able to import a lot more of their processors, their receivers, kind of the whole ecosystem. In fact, if you go look at OTel's website, you'll see that we're listed as distribution in certain places and has supporting these components in others. So that really allowed us to, be more native in OTel. And ideally, we're currently working on the ability to do config conversions. So that's kind of maybe not a unique, it is a unique feature to Flow where we want people to get on Flow, and we recognize that having people rewrite their configs was going to be very painful. So because no one wants to do that, right? No one wants to be like, oh, I've got this new thing.
It's not sexy development.
Yeah. So what we've done is for the Prometheus and for static mode, we've written converters that allow you to, in most cases, there's an asterisk, it's like 95%. You can dump your config and it will generate a river config that does the same thing. And you can either export it to a file or you can just run it and it will just run. And we're going to be, extending that to more of OTel things to kind of be able to be, like I said, the plumbing, we don't want you to care necessarily about the protocols and the kind of get into the weeds of things. We want you to be able to move signals like the concept of a signal, whether the actual format of it is from point A to point B. So that's some of the neat features we're doing to Flow. Flow also, we're opening up the ability to do more beyond just telemetry and signals. So we've got like rules that it can sync your alerting rules, recording rules to from like a CRD in Kubernetes to a Mimir cluster, which is something that didn't exist in static, and would allows kind of, so this is a unique developer feature of Flow. We have gotten 10x the number of contributions from the community for Flow and Flow components, because one of the, going back to the original conversation 2 years ago, is we recognized that development was hard because there's all these magic connections that aren't apparent with the static mode. And with a component where each kind of component acts as a black box that just has inputs and outputs, you don't have to worry about how it fits in the ecosystem. If you want a component that, I don't know, adds something to every log, you just have to build something that accepts logs and then sends out logs, and the Flow framework around it will handle getting the data to and from it. And so you can really focus just on your business use case. And so that's opened up just a world of contributions.
Oh, that's cool. So I mean, so there's a lot of different. So like I know in the Terraform idiom, it was always like the providers and things like that. Do you have? And I know you mentioned HashiCorp Vault for getting
Hmm.
secrets management out, but has somebody contributed already for like AWS Secrets Manager or
I don't know
anything like that?
specifically for that, but yeah, we've had several contributions that are just full components.
Uh,
Probably, if I was to ballpark, 6 or 7. Actually, probably more than that, because I know one person did 4. So there's considerably more components, and I forget how many we're up to now. But we're seeing a lot more like just contribution that we rarely saw, very rarely large contributions with static mode. People would contribute like a tweak to a setting or a
mhm.
bug fix, but we're seeing just full on new functionality being enabled via Flow, and that's really exciting to us as developers to try to build a community around it.
Yeah, that's good.
You talked about a conversion, some scripts that you wrote that convert the configuration if people are already using static mode and they want to try it flow. But what if people haven't used it yet and are just now getting into it? What's the installation like? The differences in them? Because with static mode, I know there are quite a few installation options. Like we talked to Pascalis, who said like there's Docker, there's Kubernetes, and different operating systems. So there's a standalone
Mhm.
binary. There's also a Helm chart, right?
Yep. Yeah, so we have Helm charts for Flow, and we also have RPMs and DEBs packages for Linux for Flow that are pre kind of baked in. Any agent executable inherently can run Flow. There is a environment variable, agent underscore mode, and if that is set to Flow, it'll be in Flow mode. So every executable supports both. So if you since we released Flow probably a year ago, maybe 8 months ago, something like that. So every executable since then has the capability to run both modes based on an environment variable. If you get the Flow one, essentially, if you get the Flow mode only ones, I don't know offhand if you can go back to static mode with those. But I guess the intent is if you're downloading them specifically, you're already in Flow and don't need to kind of
You're
convert
all
there.
in.
Yeah, yeah. Technically, there's probably a way to get around that, but that's the intent. If you're downloading a Flow specific one, you're moving forward there.
So one of the recent changes is in Grafana Agent I saw was that it now supports continuous profiling via Pyroscope.
Yeah, yeah. There's a component for it. You set it up and you set it where to export it, and it'll run. I used it not too long ago to identify some CPU
Yeah,
high CPU usage in the agent itself.
nice.
All those flame graphs.
Nothing demo sexier than a flame
Flame
graph.
graph, yeah,
It's-
yeah. And what was really cool was the diff in the Explore tab of the. I was talking to Ryan about it at the KubeCon, and so I was able to kind of nail down where some performance was being eaten up in one of our components.
nice.
And was that something that was available in static mode as well?
I don't think Pyroscope was available in static mode.
Okay. So what's the deal with that?
Mm.
I know there's feature parity already between flow mode and static mode. Is static mode going to go away? Like, what are the plans there?
On a very long timeline, I mean, flow mode will be the primary thing and that we will push. Static mode will be around for a long time. It is in use by customer. Again, if you're happy with it, we want to keep supporting it, and we'll make sure that it receives, security, some quality of life updates. A majority of new work is going to go into Flow. So if you're happy with static mode, you can continue using it for a very long time.
Yeah. Hopefully, with the converters and everything, it's a painless process and folks can adopt it.
Absolutely. The idea is people, we want to make it super easy for people to move to it, and we have we have a channel in our community Slack agent that like we love seeing questions about flow because like it's what makes us really excited. And if people come with their questions, we are very excited to help answer them.
Nice.
All right. And what else do you want to see happen in flow mode? You don't have to
Oh
commit
man.
to timelines or even that things will definitely happen, but like, what would you like to see?
So this is we're going to get a little out into the weeds here. I don't know if these Americanisms fully come across, so I apologize in advance. The Something that I am excited about that we're kind of changing up a little bit is we have this concept of modules, which are kind of like pre-packaged river configs that you can basically import into yours and get functionality. And we have a whole repo with those in it, although we're changing the structure a bit. So this is some preamble here where I'm excited where it's going to go. And we really see a world in which most people who are working with the agent, they really just want to solve a problem. I mean, that's really with most things you're trying to do. You don't want to get it too much into the weeds. You just want to solve a problem. And we think modules are going to be a really good way to do that because that's essentially going to be a listing of prepackaged solutions that we have. Maybe it's something like grabbing IIS logs and sanitizing them. And we've had people here at Grafana in the community have looked at this and kind of said this is a best practice. And ideally, you pop in 4 or 5 lines into your river. It imports a few hundred lines of river essentially and runs it, and you're positive and you're just happy that you like it's best practices. It works. It kind of sets things in a way that we expect it, and you don't have to think about it. You're just like, boom, give me that. We've got some things that do basic sanitization of like logs. So we try, obviously, do your own research uh, thing of like trying to pull out credit card numbers, names, some stuff like that that we hope kind of we build up a library of. This is a good place to start. Obviously, depending on your use case, you may need to scrub more data out of it, but it gives you a starting point. And that's where that's something I'm pretty excited about is seeing those modules grow and kind of get feedback from the community. And it's also a touch point with a lot of the other internal teams here at Grafana where they're building modules for like integrations that we can kind of package up together and people can just write to about 5 lines and get that functionality and not have to think about it.
Yeah, it's too bad there's already an RPM, right? We could call it River Package Module. So
I'm gonna go ahead. We're doing that now. I'm gonna write it down.
It has to be like, water themed, so something like
Yeah.
or
Yeah.
something like that.
It'll be a mug or a pint, maybe.
Go with the home
Download a
basket.
Wrong
pint.
liquid.
Yeah.
I'm down with this idea. So
Yeah. So it's kind of, is it like groups of components that solve particular problems?
yeah, so we've got some they are a collection of rules or components, any sort of river configuration you could want that essentially we pre-package in a way that we say we've looked at this, it's trustworthy. And we're kind of doing a little redo of it now. Once we get that redo a little bit more, you'll find more linkages from like our docs and more of the more task-based documentation. Where when I say task-based, I mean it's like trying to solve a problem. I want to scan my I want to get my Windows metrics. And you can get a Windows exporter and you can set the defaults and all that. But I would bet most people probably have similar use cases. And so we can have like this prepackaged thing that is basically like, hey, just import the default Windows exporter rules and it will work for 99% of the cases and you don't have to worry about it. The other advantage is it's in a GitHub repo. So if your organization wants to adjust it, you can fork it and just adjust it and add your own special sauce to it, or do anything else you kind of need to apply things to it. So I think that's going to be an exciting future for Flow, is the ability to kind of share configurations in that way.
That's cool.
So, Matt, I'm going to spring something on you here.
Okay.
I saw
I'd
it
like
coming
to,
up.
yeah, I saw you see it, Paul. You spoiled it for sure. So I would like to do a summary of what we've just discussed. There's a game that we sometimes like to play here at Grafana Office Hours. You know this stuff, so I don't think it's going to be a problem. But it is a sort of podcast game
All right.
where we talk about what we've just discussed, but we do it in 5 minutes. There will be a name that comes up, and that person must then talk. And then the next name that comes up will have to follow on from the person, from whatever the other person was saying. You can finish your sentence, but you have to continue the flow. Are you up
Oh
for
my.
it, Matt?
Let's go. Let's rock and roll.
All right. See, this is how you should be like, Paul. Matt's like, yeah, rock and roll. You're always whinging about
See,
it.
I always do horrible at this.
All right. That's why it's fun. Let's see what happens. So today we've been talking about Grafana Agent, which is a vendor-neutral, basically signal collector. We previously talked about this on office hours, but it is a binary that you can drop on to anywhere pretty much.
And with the new flow mode, you can chain together different components.
To create a data pipeline that allows you to really handle any sort of transformation and to move any kind of signal.
And you can transform it, and you can do a lot of things that you couldn't previously do with static mode. One of the things that made static mode so hard was that it is written in YAML.
And you couldn't do cool things like write to multiple Prometheus remote write endpoints at the same time.
And the flow mode allows you to also do things just outside of normal Prometheus metrics, such as open telemetry and the ability to kind of pull in other things like Mimir rules and be able to write those.
And it's also moving it in the direction of this Big Ten philosophy that we have, where flow mode can handle all the OTel stuff.
For logs, metrics, traces, which were already OTel, but now we have all those supported. And then one of the other fun things that are coming up with the flow mode is the support with clustering.
Yeah, and clustering expands upon the ability for agents to be more reactive to changes and to be scale up and scale down in a much better manner than hash mod sharding allowed.
Which is what the previous mode, static mode, was supporting. So the problem with hashmod sharding is it might be good for scalability, but not so much for availability.
Right, and you'd always have to manually configure your shards for that. Whereas with the clustering mode, it will automatically resolve for growing and shrinking your cluster.
Another awesome feature was the fact we now have built-in UI that you can look at a graph to see how the DAG itself is built. That kind of shows the health of the components and documentation links.
This is super important when you think of the fact that you might be getting lots of telemetry signals. And actually, one of the other advantages is flow mode can do more than just telemetry.
Right, and with those DAGs, which is not a Dagwood sandwich, it's actually a directed acyclic graph. So it's
I don't even know what a Dagwood sandwich is, but I've seen it on the menu at a few places. But I
The
guarantee it's
giant
not
one.
direct acyclic graph.
Another advantage of flow mode, speaking of things that are not sandwiches, is that it also has led to better community contributions because it's just easier to extend, and developers have already come out and done a lot of cool things with it.
Right, and then we're looking forward to future updates where we'll have these in packages, not to be confused with river package modules, RPMs that's already taken, but packaged modules with multiple functions.
Yeah, and these modules they'll really allow us to drive contributions in terms of what we think is common functionality that most people can use.
To be able to solve a particular problem. So they don't have to think of the individual components anymore. But if you are already using static mode and you're worried about things going away,
Then you can use the converters to convert or use the convert once to rebuild a config and then build off of that and see where it takes you and allow you to really dig into the expression based language.
and also if you are trying to start with a Grafana agent right now, then what you should probably start with is now flow mode, because that's really where all the development is happening. It's also better documented.
In flow mode is just simply the future. Oh man, I got less than 10 seconds. Flow mode. Okay, wait.
Come check us out
Scan.
at the community channel,
Oh, look at you.
Agent,
The
and on
drone
our GitHub
lifesaver.
forum.
And next week, we are going to be talking about something else entirely. We're going to be talking to Joseph Elliott all about Grafana Tempo. Thank you to Paul and Matt for joining me on this whole episode and also in the last 5 minutes.
Thank you so much for having me.
Always a pleasure.
We will leave all of the links to the resources that you're going to need in the description below. Thanks everyone for watching and see you next week.